No. What happens with an ellipse is that when you're dealing with an ellipse is that there are values of A and B that stay constant, the sum of them between where their foci are at. Foci is the plural of focuses, or focus, excuse me. So what happens here, when you have an ellipse, this value, as you drag it around the ellipse, the distance, the sum of the distances there, distances, whatever you want to call it, it stays constant. They stay constant from those two fixed points from the focus. Now, this actually does occur in a circle, but we don't look at it in terms of circles, because circles become a more specific form of an ellipse. Just kind of like a, what is it, a square is a rhombus, but a rhombus isn't a square. Remember that whole thing? It's kind of the same idea. What happens here, and I was showing on this just a second ago, when you have your x squared, y squared equals 16, thank you, we knew that the radius would be 4, okay? You would just take the square root of it and you went through there. What's going to happen with the ellipse is that the ellipse is going to have equations that equal 1. 16 over 16 is 1. Hi! Hi. So you get that. What I want you to see here is that these values are identical. Those values will become today the A's and B's. That's how you can distinguish between the circle and a rhombus. Yeah, I hope you can tell the difference between a circle and a rhombus. The circle and an ellipse. Hope we get the point on that. What?
Unlike the test stuff, will you ever make it so close to a circle?
No, because what will happen on a test is that your problems are going to look like this. Well, not specifically this, but where is it? It'll be something like you'll be given that, you'll have to go through and complete the square to get the generic form to figure out what you have. You're going to have to figure out the differences in the generic forms. You'll be given this. Complete the square and identify all the parts. Knowing how that stuff works as we go through them, because we still have, it's missing my breeze. As we go through these things, you'll start to identify how easy it is to identify between the parts. And today is going to be the first step into one of the goofier ones, the ellipse. So, I'm just going to jump right in and scare you with the forms. There's a lot going on. There are two forms of an ellipse. You're going to have an ellipse that's stretched horizontally, and we're having an ellipse. Hi! I missed you! Tell them conics are fun.
It's super fun. It's calculator does it.
So you're still missing.
Yes.
And yours is still long.
Yes.
You have something.
I do. But conics aren't one.
What is that?
All right. So what I want to do here is I want you guys to see where these parts are coming from. It looks like it's going to be awful, but once you start to work with how this stuff is, they wind up very easy. Today what we're going to do is everything we do for our ellipses will be centered at the origin. We're going to have a horizontally stretched one, and we're going to have a vertically stretched one. When you are stretched horizontally, your vertices go horizontal. So today our vertices are going to be marked at some value of a, comma, 0, and negative a, comma, 0. Since we're centered at the origin, the distance from the center to a vertex is A. So the distance from your center to vertex is A. This B value is going to be the distance from the center to what's called a co-vertex. So if my vertices went horizontally, my co-vertices go vertically. And we call that the value of B. And the only reason why my ordered pairs are at 0, B, 0, opposite of B, A0, negative A0, is because the center today is at the origin. Tomorrow will be at like 2, 5. So you're going to have to add and subtract some A value to 2, 5, or B value to 2, 5. So the distance from the center to the co-vertice is B. And then just like we had in parabolas, we had a focus. Your vertex always looked at a focus. Same deal. The vertex is looking at the focus. Well, since our vertex are looking inward at each other, the foci, plural of focus, are also inside. So the distance from the center to the focus is going to be this value of C. Here we have it at C0 and negative C0. Well, the generic equation for today for horizontally stretched ellipse is going to be x squared over a squared plus y squared over b squared equals 1. How we're able to distinguish A's and B's is going to be very easy. The A squared, is always the bigger number for an ellipse. The A squared will always be the bigger number. That's how you're able to tell whether it's stretched horizontally or vertically. If the A squared value is underneath the x squared, it's horizontal. If it's under the y squared, it's vertical. It's that plain and simple. Right? It's that plain and simple. And I'll get to how we figure out C here in a second. We do the same idea with the vertical one. If it's vertical, that means stretched up and down, so your vertices are up and down. Your A value still is giving you the distance from your center to your vertex, so now the A values would be at 0A, 0 opposite A. Your co-vertices go left and right, because they're horizontal then. What's wrong, Shinky? Okay.
No, I was just moving the.
Co-vertices will be at B0 and negative B0. And where do you think your foci will be if you're stretched up and down? We have on the y-axis here. Okay. So we have a vertex, we have a focus, and we have a co-vertex. Yes, sir?
Are the foci like a property of the ellipse, or is it just any point?
It is a property, and that's what I'm getting, because we're going to have to be able to figure out what this value of C is. And when you're dealing with an ellipse, to solve for C, it's the same thing whether it's stretched left and right or stretched up and down. Your C squared term is going to equal A squared minus B squared. For either one, whether it's stretched horizontally or stretched vertically. The value of C is found that way. And I can guarantee you, after you see one example, maybe 1.5 examples of how this stuff works, you guys are going to be like, oh, this is ridiculously simple. Because it's just a process. Labeling out and counting. That's it. Okay? You'd be very, very pleasantly surprised at how simple this is. Okay? So when we're dealing with an ellipse, if it's A squared is underneath the x squared term, if that's larger, it's stretched left and right. If the A squared is underneath the y squared, it's stretched up and down. And with the ellipse, and then eventually when we talk about hyperbola, they're always going to equal 1. Okay, so we're going to have to set sides equal to 1. Yes, sir?
I took a look ahead of in the book.
Yeah.
And I noticed that there's a lot of like there's 2 equations for every.
Yeah.
Will we have to remember all of them?
If you recall, I told you that there is a button on your calculator that says apps.
Oh yeah.
Those forms, the formulas and stuff are already in there, and it tells you basically the same idea. So if you do this, if you look at it now, if I go to my apps and look at my conics, and then if I look at ellipse, it's going to give me the form shifted with an H and K. Right now, my H and K is 0. So we do have a H and K here. They're just represented by 0. So it is x minus 0 quantity squared, y minus x, and then y minus 0 quantity squared as well. If you don't have conic app on yours, we'll put it on there eventually. It's not a big deal. It just takes a second. Yes, ma'am. Just to show the difference. That's all. You notice the little picture, one stretched left and right, the other one stretched up and down? Also a nice way to remember that.
So are we going to be able to use this?
Well, at least it tells you the formula.
But so
If I don't let you use the calculator, what I've always done with this section, I think you should see it, is that I take a screenshot of what it looks like on your calculator and I make a little cheat sheet for
so
it.
we won't have to move
Maybe, maybe not. Yes, ma'am.
So depending on whether it's a horizontal. Yeah.
Yes, remember the a squared is always the larger of the two. Whichever one is the bigger number, that is a squared. Okay? For an ellipse, a squared is the bigger of the two. So let me show you an example and walk you through how I would set this up. What I want to do is not just identify the foci. I'm going to graph and label everything. And I want to get you guys in the habit of doing that for all of these, to graph and label everything. Because the more preemptive we work on it now, the easier it becomes when you shift it. Because once we shift it, it's remembering what direction things go, it can get a little muddy. So we're going to use the ellipse with the equation 9x squared plus 16y squared, and it equals 144. And I'm going to graph and label everything. Yes, sir?
Okay. I am afraid of getting ahead of myself right here. But like this is already in what's it called, Pythagorean theorem. So like A, B, and C are already set up for us, sort of, right? So can't we just squared plus one?
It's a squared plus b squared is c squared. Here we have c squared is a squared minus b squared.
Okay.
So the first step, I'm looking at something like this. I have to get it equal to 1. How do I do that besides subtracting 143? Divide by 144.
Okay.
So 16 over 144 is 1/9. So this is y squared over 9. And it's going to be x squared over 16. Now I'm in the standard form of an ellipse. I have x squared over a number plus y squared over a number equals 1. Yes, ma'am? No. Well, you can, but you have to do a lot of work that you have to do by hand anyway. In this case here, which one is a squared? The 16 is a squared, so which way is this stretched?
Why?
Left and right. So what I want to do, once I know that it's going to be stretched left and right, I'm always going to do I'm going to draw a little diagram so I know which way I'm going. Yeah.
It was a question about something else.
Okay. Ask.
Can I ask it?
Yeah.
Okay, so you know how we were doing circles yesterday?
Yeah.
Could you ever have like an x squared minus y squared thing?
That'll be Friday we do the hyperbolas.
Okay.
Okay. So now when we do this, we can start to identify our parts. So what I always do is label. A squared is 16. B squared is 9. What's A?
4.
Or,
Negative 4.
good. So A is going to be plus or minus 4. B, plus or minus 3. I know the formula to solve for C. C squared is A squared minus B squared. Therefore, C squared will be 16 minus 9, which is what? 5. If C squared is 5, what's C? Oh yes, 7. But yeah, just seeing if you. I believed you. You just I don't know. So you get the value of C is just plus or minus the square root of 7. We okay with that? So now you go through what you know. Well, A is the distance from the center to vertex. B is the distance from the center to co-vertex. C, distance from the center to the focus. By remembering what each of those values stand for, it is so simple to plot them. We know our center is located where?
0,
0,
0.
0. We have a center at 0, 0. I have my A, my B, and my C. What I'm going to do here is put this on a separate dual side and see if we can make this work. Okay. And I know that I can go ahead and graph it. I'm not using graph paper. Graph paper is for
The week.
chumps, for the weak, the feeble-minded. No offense if you're using graph paper. I'm not making fun of you. I'm just
Yes, you are.
saying we don't need graph paper. My center is at 0, 0. I know it's being stretched left and right, so to go to my vertex, all I have to do is walk left and right. How many? 4, because my A value is 4. So I have vertices at 0, 4 and 0, negative 4. Please don't write 0 plus minus 4, because that won't work when we shift it. Okay? Get in habit right now twice. Did I say, I said 4 and 0. Oh, my bad. I thought I said it that way.
Gosh darn it, Murphy.
I didn't mean to.
I wrote it in pen.
After that, my co-vertices go vertical. They go up and down, what, 3 I believe for my B value? So if I don't screw this up. So the co-vertices, 0, 3, 0, negative 3. And now the last thing I have to put in, the value of C. C is the distance from your center to your focus, and right now we have it at the square root of 7. Well, last time I checked, the square root of 7 is more than the square root of 4, but less than the square root of 9. It's probably closer to the square root of 9 than it is the square root of 4, don't you think? So would I say like 2.6, 2.7, something like that? So as long as I'm somewhere on the graph between 2 and 3, is it okay?
Yeah.
That's all it is. So then you have focus. It's on the horizontal, so it's root 7 comma 0, negative root 7 comma 0. And just draw your circle, or ellipse, excuse me.
Beautiful.
Wow, that was pretty bad. Am I supposed to do what? No, it's just going the other direction, root 7. It's not the square root of negative 7, it's negative root 7. Or just because I'm moving it to the left.
Oh,
Okay, does that make sense, Ricky?
not really, but
If you're moving to the left off of 0, you're subtracting. So I'm just moving to negative
So
7.
why would you use I? It's not just the negative version of it?
No, because I is the negative square root. It's the square root of the negative. This is the negative square root. This is -1 times the square root of 7, not
Trust you.
Just means
You're right.
it just means I'm moving left. That's all it is. Okay, that's all it means. All right. Now, yes. Oh, what I want you to see here is that
Somebody's here.
it's not really difficult to go through it. It's just a matter of setting it up and piecemeal the parts together. Couldn't tell you the day to look this up either.
Can I tell her?
No. And I got to call timeout because you had it.
Yeah, wow.
All right. Now she's gonna look at this and go, no, I didn't collect it. So let's do another one.
Can you give us time to do it first?
Yes,
and then-
absolutely.
Mr. Murphy, variables are switched.
I know.
Oh, sorry.
I'm doing that on purpose.
Okay. We should watch that video.
I did that on purpose. That way we do a different shift.
Oh,
Stretch it over. That's all.
Video.
sorry.
You just threw your thing off the page.
What the heck?
So, excuse me. So in this one here we have 25x squared plus 4y squared is 100. Very good. Divide everything by 100. Don't subtract 99. Don't take.
It's $9.99.
It's a joke, guys, because it's just a joke. You have to divide by 100 to make these work. Okay? You can't just. It's just me being classic Ruby. All right. It was just a joke. You have to divide. Always have to divide.
What would happen if you?
It won't work.
Let's take the shortcut.
Yes, sir.
Are the A and B always going to be factors?
What's that?
Like, are A and B always going to be factors?
Dumb luck.
Okay.
Dumb luck. A lot of times they give you A's and B's that tend to be perfect squares.
Okay.
Don't get me wrong, you can get weird ones. I mean, you'll get square root of 10. It's not that difficult because all you're doing is just moving up and down and just labeling the ordered pairs. Okay. So when I do that, I get what? X squared over 4,
Uh-huh.
Yes.
y squared over 25.
Wow, Mr. Murphy, you're really good at math.
Thanks. So now, which one's bigger, 4 or 25? 25. So therefore, a squared is 25. So what direction is this being pulled? Being pulled up and down. So I know that right away. I'm going to draw that so I know that in the back of my mind, my picture should look somewhat like that if I do this correctly.
Yay!
All right? Start labeling. Your a squared term is 25. Your b squared term is 4. C squared comes from a squared minus b squared. Well, a plus or minus 5. B plus or minus 2. C squared, let's see here. We get c squared is going to be 21, I believe.
Yes.
So the value of c would just be plus minus root 21. I'm very glad you're so, I don't even know what to say. Never mind.
Intelligent.
Something.
I'm not sure intelligent is the word you would be for.
Where is this
I'm
thing
not
centered at?
Zaza.
Centered at the 0. Centered at 0, 0. Knowing that this is, bless you, knowing that this has to be stretched vertically, that means my vertices have to go up and down.
Yay!
Up and down. So I know I have vertices right away. At 0, 5, 0, -5. Co-vertices are going to go left and right. Left and right, 2. And then the C value. I have to figure out approximately where I'm going to put the square root of 21. Is it closer to 4 or is it closer to 5? It's closer to 5. Think about it. If your square root of 21 is between 16 and 25, it's 4 away from the 25, but 6 away from, or excuse me, 5 away from the 16. Therefore, it means it's closer to the positive.
I tried to.
It's okay. You can keep trying. I want you to keep trying. You can do it.
You can do it.
But again, as long as you're in the realm of between 4 and 5 on your dot, it's okay. But if the ordered pair tells you that you know what you're doing, the foci would be at, excuse me, 0 root 21, 0 negative root 21. Tomorrow what will be different is that we're going to have an ordered pair that you're going to have to add and subtract that C value to. So if your
That
center
sounds
was
so
at,
fun.
well, it's not bad. I mean, if your center winds up being at, if this was 2, 3, and the C value was, I had to add the C value was, root 21, and I'm moving it left and right, my C value would be 2 plus root 21, and that's what I would write it as. Okay? I can't come up with anything else. You're going to see that it's going to be very, very easy when we shift these things through. It's just getting used to the labeling of stuff is what takes the longest. And then the last but not least, I have to do my best to draw.
These are not hard at all.
Okay?
When you say that now,
You guys and your worriness, it's great. Let's write the equation given parts then. Do this one at a time.
Mr. Murphy, what section is this?
This is 10-4.
10-4.
And if you think about it, today is 10-14. What is the significance of today's date? Goobers, let's go out.
it's 10-14, 10-4.
No.
Oh.
We're gonna be super.
Someone's birthday.
Oh, wait, I heard this on the radio. Today's the anniversary of the Bartman game. Game 6, 2003, NLCS.
Yeah, I heard that on the radio.
When they blamed the game on the poor guy in the front row.
Oh, yeah. The most hated guy in the world.
You haven't seen him since? Poor kid, it wasn't his fault.
Yeah.
It wasn't his fault. I was at that game. I would have done the same thing. You look at the Trekish foul ball, you don't know what's going on. No idea. So, voiceless Bill would never. All right, anyway, so if you go back to this, what I want you guys to see here is that you're going to be given information. You're going to be given vertex, covertex, vertex, focus, focus, covertex, some combination of those three things. My suggestion, because it usually works, is to rough sketch what you have and then remember what each value stands for. Okay, what each value stands for. In this case here, I have a vertex at 0, 7. Right away, if my vertex is at 0, 7, is it vertical or horizontal? It has to be vertical, because that's why the vertex went up. Which means also, since I'm centered at the origin, I also know that what's my A value? 7. I know that A is 7, because the distance from the center to my vertex is A. In this case, it's 7. The distance from my center to my covertex is -6. So my B value is 6. It's stretched vertically, so where does the A squared go under? The Y value. Good. So I know I'm going to use the x squared plus y squared equals 1. B squared goes under x, and A squared goes under y. What's 7 squared? And what's 6 squared?
36. Just kidding. Just
And
kidding
you're done.
about just kidding.
You're done. You're done. That's all you do. Write the equation in standard form. Done. Okay. It's the idea of knowing that distance from center to vertex is A, distance from center to co-vertex is B, distance from center to focus is C. Okay?
Yay, math!
Do you have to know C then? Or no?
Not always,
So you're not.
unless you're given something with C. It's funny you ask.
Yeah, we did it.
Guys, come on. In this case here, you are given a vertex at -4 and 0, and a focus at 2 and 0. Excuse me. Knowing what we know about A, B's, and C's, and knowing where vertex is and focus is, we should be able to tell right off the bat what direction this is going.
Down.
Careful. If I know the vertex is at -4, you were thinking that because your head was tilted.
Yes, clearly.
Just go with it.
So if my vertex is going left and right, that means it's going to be stretched left and right. Therefore, my A value is what?
Under the
4. It's going to be under the x. Good. So my A value is 4. My focus is at 2. So my focus, the distance from the center to the focus is what? 2. Okay, is it A, B, or C? Excuse me. C. So C is 2. Well, A squared is 16. And C squared is 4. So Shimke, you're just asking, well, what happens if you don't need, what happens if you don't need the C sometimes? Well, in this case, we needed the C because we have to find B.
A never be like a negative then?
Right, because the distance is always, the A squared term is what goes underneath there. The distance is always going to be positive distance when you're looking at it. You just go in different directions. Okay? So C squared is A squared minus B squared. So what's 4 equals 16 minus what?
12.
We don't have, we have to take the root of that? No. Because think about the generic form. Go back to the generic form. We know that the A squared's got to be underneath the x squared because it's stretched left and right. The generic form is in terms of A squared and B squared. You don't have to square root anything. So it's just going to be,
Super convenient.
yeah, x squared over 16 plus y squared over
12.
12.
Oh no, Mr. Murphy, that's
can't be
12.
Yeah, 16, basically think of it this way, when you're trying to solve for the B value or the A value, 16 minus 1 is 9, or excuse me, it's 4.
Oh my, oh, because it's a negative.
Yep.
And then you add it.
Yeah, JC,
Where's the 12 from?
I did this. 4 minus 16 is negative B squared, so negative 12 equals negative B squared, divided by negative 1, divided by negative 1, 12 is B squared. All I did is I did all that math by saying 16 minus what is 4. That's all. I simplified my life. I made it easier. Okay? Now, I'm not going to lie to you. Sometimes I'm going to give you weird values that you're going to have to deal with. For example,
No!
Oh, yay. He made a hole.
take a minute. Try that.
Let's not.
All right, write the equation out. We should be able to tell right away just by giving the values here that you know the direction of the stretch.
Left and right.
It's left and right. Okay. Because both your vertex and your focus are x coordinates. Centered at the origin, so it's not going to be a big deal. I know that my A term is going to be 7, because that is my distance from my center to my vertex. My C value, I'm going to negate the negative, because it's not a big deal if it's there or not, because it's going on either side there. It's going to be 2 root 10. So I need to figure out, well, A squared, well, that's easy. That's 49. C squared. When you do this, you have to type it like that and square it. It's not negative. Put parentheses in the wrong spot. What happens here is if you use your calculator, parentheses negative 2 root 10, notice you have to get out from underneath the radical. You have to move to the right, then close the parentheses, then square it. 40. Okay? That's how that one sets itself out. You just be very careful when you do that. It's very common for people to just kind of screw that up. So your C squared is 40. Remember, C squared comes from A squared minus B squared. So 40 is 49 minus what?
9.
9. Very good. So you get x squared over 49 plus y squared over 9 is 1.
Yay!
It's not. It's not. But what's going to happen is you're going to have them. Where is it?
I know I am thinking.
You're going to have stuff like this where you're going to have them bounced around at different values. You'll have to understand where they're being plotted. Once you start plotting them in space, it'll be very easy to see where they're going. And it's just a matter of counting. So I've got a couple of these for you guys to try out for tonight. Nice. All right. It's every other odd. I think we worked it out. It's like not many. Is that all it is?
13.
That's what Holly told me she did that.
Okay.
5 minutes of progress.
It's not that. Most of them aren't that long to go through. A lot of them aren't. It's not just the same. There's a good mix of problems in here. You should be able to fly through that. Hopefully, that'll give us. Plus, it's going to help us get a good chunk of this stuff done for the shifting of it tomorrow. I tell you one thing. When we do the shifting of it tomorrow, it's going to be so much easier because you did a little bit more of the work today. Because it's the same stuff, it's just different ages. All right? So what? Oh yeah, we go back to chapter 6 next. No.